Welcome to Complexity Made Simple. My name is Paul Allen, and today we're going to do a software tutorial. We're going to take a look at the software of choice that I use in Six Sigma. We're going to look at SPC XL. Hope you enjoy it.
Okay, this latest tutorial with Sigma Zone SPC XL again. Today we're going to take a look at, in the analysis diagrams menu, we're going to take a look at the summary stats and the dot plot. Once again, we're using variable data, measurable data. We're going to use this data over here. I shall just highlight it for you and put it in some bright fields. There we go. I'll put it in the yellow fields. So they're the data sets that we're going to analyze. We're going to create summary stats and we're going to create a dot plot. The dot plot, as you'll see, is a particularly simplistic diagram, but what it enables you to do is to quickly analyze data sets. So if you have 5 machines that are all producing the same product, or the 5 machines all get the interchangeably make products, and you think one machine is completely different to another one, or the machines are not the same and they're giving you problems because of that, the dot plot quickly enables you to compare sets of machines, and you'll see that in a moment. So let's just to show you this. So what we're going to do is highlight the 2 data sets together. So highlight the data. It's the standard way with Sigma Zone that we highlight data first. Then I'm going to go analysis diagrams, summary stats. And again, the little wizard opens up and it always asks you, is this the data set that you want to analyze? In this case, yes it is. Next. Now, because I've highlighted a block of data, the software recognizes this and it's saying to me, well, okay, look, do you have one group? Do you have data sets which are in columns? Do you have data sets which are in rows? So obviously I've got 2 data sets in columns. Click columns and then next. And then it asks me, do you want to look at the dot plot and the stats? Do you just want the plot? Do you just want the stats? Well, I would like both. Obviously I'm showing you what happens here. So we'll click OK to that. Here we go. Unfortunately, with Excel functionality, it leaves an awful lot of dead space in this diagram. I'm quickly going to right click and format axis, and I'm going to take that minimum down to 40. Click enter, and I'm going to take all the dead space away on my dot plot. There we go. So there are the 2 data sets, and you can see, look, that one data set is much more spread. There's a couple of flyers out here. Here's the other data set, much tighter. Of course, when we look at the summary stats, we'll be able to summarize this in terms of the signal, the mean or the average, and the standard deviation, the spread. And we'll be able to look at the mean and the standard deviation, the signal and the noise for the 2 data sets. But visually, we can see that these 2 products, and that's what this data is, it's product data. These 2 products are very different in terms of their average, their signal, and their spread, their noise, their standard deviation. So there is the dot plot diagram. As I say, if you've got 2 or 3 machines and you quickly want to compare them, this is a nice simple diagram to visualize the difference. Next door to that, I have the summary stats data. So let's take a look at this. What's it telling me? Well, it's telling me how much data I had. Look, there's the count, 445 data points against 95 data points. It's telling me the mean, what we would commonly term the average in ordinary everyday discussion. Then it's telling me the median. The median is the middle number if you rank all the numbers in order. So if you have 1,000,000 numbers, you put them all in order, you go down the list until you reach number 500,000, and that middle number is the median. As a reminder, folks, these numbers here, the mean, the median, and the mode, they are all estimates of the middle of the data set. They are different ways of estimating the middle. Then I've got the maximum, the minimum, and the range. I have the standard deviation. Another way to describe the standard deviation, it is the average spread of the data. I have one for the population and I have one for the sample. A simple thing to remember, folks, the sample is always correct. Always use the sample. That is always the correct number. Then below that I have the variance, because again, the variance for the sample is always correct. The variance is simply a squared version of the standard deviation. The only reason it exists, obviously in this case, these numbers are in decibels, so the variance is in squared decibels. It's a really strange number. Why would we calculate the variance? Because if you're adding variability together, you can only add variances mathematically. You can't add standard deviations together. So if you have two standard deviations, one's at 1, one's at 2, you add them together, you don't get a total standard deviation of 3. That's not the way it works. You have to square them, and then you have to take the root to find the real answer. So that's the only reason the variance gets calculated. It's because we can only add variability through the variances. And then finally, I have something called the confidence intervals. So down here we have confidence intervals. One of the things, if you've been in one of my classes, that I would have introduced to you, every number you look at in mathematics is an estimate. That is the sensible way to think. Every number you look at in business is an estimate. And if you realize that it's an estimate, the next sensible question you would ask is, how much of an estimate is it? Statistics is full of tools that tells you how good the estimate is, because it knows it's using an estimate and therefore it gives you help. It tells you how good the estimate is. The confidence interval is telling me how good an estimate the mean is. So we're looking at this number at the top, and then it's telling me how good an estimate the mean is. So that's what the confidence intervals are telling you. This is sigma zone, this is summary stats. There's your summary stats so you can compare the two data sets. There's the dot plot so you can visually compare the two data sets. Sigma zone, dot plot, summary stats.
Well, I hope you found that useful. If you've got any questions about that topic, or indeed anything to do with Six Sigma or Lean for that matter, give me a call and I hope to hear from you soon.